Hello everyone. Today you will see the unit number 1, that is the design of machine tool gearbox. So the contents of this unit are the introduction to machine tool gearboxes, design and its application, basic consideration in design of the drives, determination of variable speed range, graphical representation of speed and structure diagram, ray diagram, and selection of optimum ray diagram, gearing diagram, and deviation diagram. Now first, so what are the basic consideration in the design of the drive? So the first consideration is the speed increment range should be 10 to 15% of respective speed values. Then no stop operation while changing the speed. Then any speed to any speed possible directly. So the without stopping of the operation, there should be a change of the speed. So our drive should be designed in such a way that there will be a stop with changing of the speed can be possible without stopping of the electric motor. Then any speed to any speed possible directly means there should not be any subsequent required to pass from first speed to second speed to third speed. So the any speed change should be possible directly. Then no auxiliary arrangement or counter shafts. Then only regulating gears to be engaged. The minimum number of components should be there in the drives or design of the gearbox. Then centralized control unit should be there in the gearbox. So these are the basic consideration while designing of the gearbox. Next is design of the gearbox of machine tool. So there are various types of machine tool you can see in the diagram. So first machine tool is a lathe machine, second is a shaping machine, third is a milling machine, and fourth one is a drilling machine. So here in diagram also you can see the gearbox is located between the prime mover and machine tool. So the first will be the motor, that is the source of the energy. Then second will be the gearbox, and third will be the machine, that is the machine tool. So the for motor speed there will be the single input speed, and for spindle speed multi speeds are on the spindle speed, that is nothing but this is the spindle of the machine tool. So here there should be a multiple speeds are on the spindle shaft. Next, how multi speeds are available on the spindle shaft. So here you can observe the or why multi speeds are required. So this is the diagrammatic representation of the conventional lathe machine. So you can see here on conventional lathe machine we can perform the different operation like turning operation, threading operation, groove operation, then fillet chamfer operation. So these all operations can be performed at the different speeds. So there is a need of the multi speeds in spindle of the lathe machine. Now this is again gearbox is there. So the spindle shafts are there. So different speed ratios can be obtained for the vehicle or this gearbox. So this is again a diagrammatic representation of the gearbox which have a number of set of the gears, and by this set of the gears pairs we can get the different speed ratios or different spindle speeds. So this is again another diagram. So how the multi speeds are available on the spindle shaft. So by using the set of these gears, the engagement of the speed ratios can be vary, or different spindle speeds are achieved in with the help of drive. The need of the gearbox. So to overcome the variation in the resistance and tractive effort of the vehicle at various speed, the transmission system is necessary. Also the machine on the shop floor, the demand of variation of the cutting speed, feed speed needs gearbox. Then types of gearbox: the sliding mesh gearbox, constant mesh gearbox, synchro mesh gearbox, differential gearbox, and all geared headstocks. So these are the all the types of the gearboxes that can be used for the design of the machine tool. Next, this is the diagrammatic representation of the sliding mesh gearbox. You can see clearly the sliding mesh gearbox. So here clutch shaft is connected with the input shaft, then clutch gear is there. Then second and high speed gears are mounted on the main shaft. Then first and reverse gears is located, that is a D. Then on lathe shaft or counter shaft, different four types of gears are located so that we can get the different spindle speed. So here on a main shaft, which is called as a spline shaft, so the gear A, F, and D can be slide over that main shaft so that it should be engaged with the E, C, and G. So we will get the different speed ratios using the sliding mesh gearbox. Then in sliding mesh gearbox, spline main shaft on which the gear F and D can be slide. On clutch shafts, gear is provided with which is always in mesh with the largest gear on counter shaft. So all the gears on counter shafts are fixed in position of reducing diameter from input to output side of the gears, and such they are all rotating when engine is in running. So this gearbox is provided with 3 forward and 1 reverse speed. So first gear is a clutch BCD main shaft, then third gear is a clutch shaft to F main shaft, then second gear is a clutch shaft BEF main shaft, and reverse gear is a clutch shaft to BGD main shaft. Next, second one is a constant mesh gearbox. So this is the diagrammatic representation of the constant mesh gearbox. So you can see the spline main shafts are there. So there are various gears are mounted. That is, there is a reverse gear, low gear, second gear, then clutch gear is also there. And on the lay shaft or counter shaft, there are again a set of the gears are there, so that we can get the different types of speeds with the constant mesh gearbox. So the similar to that of a sliding mesh gearbox, but the differences is only that in this type of gearbox, all the gears on lathe shafts are in constant mesh with corresponding gears on the main shaft. The main shaft gears revolve freely on bushes, while gears on lathe shafts are fixed. Therefore, the spline on main shafts and dog clutch is mounted on it so that it can slide on main shafts. Helical gears are used which are quite in running. Then double declutching is required to change a single gear. Then used in two and three wheeler in combination with other type of the gears. So see, this type of gearbox is used in the two and four wheelers. The next one is a synchro mesh gearbox. So this is the diagrammatic representation of the synchro mesh gearbox. So you can observe here B, C, D, E are the number of gears, and U1, U2, U3, and U4 are the gears are mounted on the lathe shaft. And clutch shaft, you can also see the clutch shaft on which one gear is located. Then we can have the different mechanism S1 and S2 for the synchronizing the speed of in for using the gearbox. So the purpose of synchro mesh gearbox is to take the gears changing easy, simple and noiseless, so that even unskilled driver can carry out the gear changing, operating without the occurrence of clutches and without any damage of the gearboxes. This type of gearbox is similar to the constant mesh type of, in that all the gears on the main shafts are in constant mesh with the corresponding gears on the lathe shafts. So the gears on the lathe shafts are fixed to it, while those on the main shafts are free to rotate on the same. So its working is similar to that of a constant mesh type, but the former there is a one definite improvement over the latter. So this is the provision of the synchro mesh device which avoids the necessary of doubt declutching. So then next one is a differential gearbox. So this is the type of the differential gearbox. So you can see the differential gearbox, which is generally or mainly used in the heavy duty application or heavy load application is there. It consists of one main ring gear and another are the planetary and sun gear is there. So from the propeller shaft, the speed is given to the differential gearbox, and it can vary the speed for the wheels while turning to onto the track. So this is the application of the differential gearbox. So that in differential gearbox, the mechanism consists of a bevel gears A and D and planetary bevel gear B and C. So the planetary gears can be rotated about the common axis of the gears A and D. So first, by means of ring gear figure, a differential is used in the automobile, and by means of T-shaped shaft figure B, this differential is used in the machine tool. So the differential gearbox having a two application. One is a automobile, used in the automobile vehicle, and second one it is used in the machine tools. Then last one is all geared headstock. So you can observe this is the headstock for the, this is the gearbox layout for the machine tool gearbox. So here you can observe that a pulley arrangement is there. So the prime mover speed is given to the input shaft through the pulley. Then you can see the shaft number 1, shaft number 2, and shaft number 3. So the shaft number 1 is the input shaft, shaft number 2 is the intermediate shaft, and shaft number 3 is the output shaft. Then you can see the output shaft is connected with the spindle of the machine tool. Then the shaft number 1 is the spline shaft, and shaft number 3 is also spline shaft, while the shaft number 2 is called as a lay shaft or counter shaft. So the number of gears located A, B, C on to the input shaft, and G, H, I on to the output shaft. Then number of gears are mounted on to the counter shaft, that is the intermediate shafts are D, E, F, so that we can get the different speed ratios by using this gearbox, so that we can get the different spindle speeds on to the machine tool. So this is the two-stage gearbox. So number of shafts are 3. So this type of gearbox is called as a two-stage gearbox. So this type of gearbox is mainly used in the machine tool gearboxes. So thank you for watching the topic gearboxes in machine tools as well as in the automobile unit.